All right, we're going to run through questions 2 and 3 from the integral as an accumulator of change multiple choice set. These were the most missed questions for the ones that have been turned in by 7:39 Monday night. So if I take a look at number 2, it says a pizza is heated to a temperature of 350 degrees Fahrenheit, is taken out of an oven and placed in a 75-degree room at time t equals 0. The temperature of the pizza is changing at a rate given by that function in degrees Fahrenheit per minute. To the nearest degree, what is the temperature of the pizza after 5 minutes? All right, so first thing here, we're really looking at temperature at 5 minutes. All right, so if we know temperature at time 0, all right, plus the accumulation of change from time 0 to time 5, for the derivative of the temperature function, all right, that's going to give us the value we need. So in this one, the function, they gave us the rate. All right, so we're going to go to our calculator. We're going to go to our y equals. We're going to clear things out. We're going to go ahead, and actually we can just do this one on the home screen since we won't need the problem for anything else. So temperature at time 0 was 350 degrees. So a 350 plus, and then we've got an integral. So we're going to go ahead and do math, number 9. And starting at 0, we're going to go up to 5 for this problem. The function we're going to type in is the rate function that was given, so negative 110 e to the negative 0.4t. All right, and then we're going to go ahead at the end and we're going to type in the variable in there. So we define what variable we're taking the integral in terms of. All right, so at this point I've got the 350, the initial, plus the accumulation of change from time 0 to 5. All right, and I hit enter, and we get 112.217. All right, so I look at my options, and the closest one we have is choice A here, which is 112. Now, one thing to keep in mind with this, if we would have done this and the temperature would have ended up being higher than 350, then what that would have implied to us is that this was a rate, but not a direction. Because occasionally what you'll see is you'll see them word the temperature of the pizza is cooling at a rate of, and then that rate function is all positive values because they've taken care of cooling with the word. So you want to watch out for that, and just a quick common sense check on the answer. Like, we expect this temperature to decrease, so if we would have gotten a temperature increase, we know something went wrong. That's one common place where that can happen. All right, I hope that helps for question 2. Let's move to question 3. Question 3 says a particle moves along the x-axis so that any time t greater than 0, its acceleration is given by that function. If the velocity of the particle is 2 at time t equals 1, what is the velocity of the particle at t equals 2? All right, so actually this problem is the same skill set as the last one. All right, we want velocity. Let's see, if the velocity of the particle is 2 at t equals 1, then what's the velocity at t equals 2? So we want to find velocity at t equals 2. All right, so we're going to take our velocity we know, which is at 1, plus our accumulation of change from 1 to 2 under the v prime. But v prime of t is our acceleration. So we're going to take our acceleration in there, so our ln of 1 plus 2 to the t dt. All right, now we know that the velocity at time 1 was 2, so you have 2 plus the integral from 1 to 2 of ln of 1 plus 2 to the t dt. So we'll go ahead back to the calculator. We're going to type that in. So we've got 2 plus math 9, which is integral. We're going to go from 1 to 2. The function is ln of 1 plus 2t, or 1 plus 2 to the t. All right, and then we'll go ahead and define the variable here at the end. And once we do that, we double check, make sure we have everything entered correctly. We'll go ahead and hit enter. And we get 3.346. So 3.346, which is choice E. All right, and that would be our correct answer on this one. So I hope you're noticing that this structure is coming up over and over and over on problem after problem after problem as we go through this. This is probably one of the biggest key ideas that College Board really hits home on. And it's a great way to solve a lot of initial value problems without going through and finding C. All right, I hope that helps. If you have any questions, feel free to email me. I'm happy to explain it another way if that helps. All right, have a great day. Bye.